Welcome to Computer Programming with Sharon. In last class, we studied single dimension array. Now we will discuss the multi-dimension array. We can create n dimensions in Java. So it can be 2D, 3D, 4D, like that. Any number of n dimension we can generate over there. In our program, we will concentrate on 2D arrays first. 2D arrays are normally using to handle the matrices. Here you can see a sample matrix is given in picture. We have rows and columns. All the indices are starting from 0. You can see the first row is 0, 1, 2, 3 and columns 0, 1, 2, 3, 4. The lower bound is 0 and upper bound will be row minus 1, that is 3 here, column minus 1, that is 4. This is like 4 by 5 matrices. If you want to give or if you want to access the array elements, we have to use both the indexes. First we have to mention the row index and the second we have to mention the column index. Just imagine if array name is A, then A00 will be the first value, that is 58. A01 will be the second value, 45. Like that, if you want to access say 69, it will be A of 1, 2 will be this. So with the example, we will try to create two-dimensional array and we will read and print the values. So we will move to the program. Here I am using an example class. Inside this class, scanner is already defined over there to give runtime values. First I have to read the row size. So I will give a prompt over there. Row size we have to enter. So I'll just give the message same thing. Then that row size I will read inside the R. Same way we have to read the column size also. So I will just copy paste this. Here we have to give the column size and column size will enter inside the C. Now the next step, we have to read the elements. We need nested loops, one to handle row, so that will write using the I loop, and the second one to handle the column, that there I will use the J as variable. So here it is row handling, here it is column handling. Now I will give a prompt over there for each and every number. For the first time, we will prefer the printf statement. Enter %d, %d element. So first d will be replaced with the row position and second will be replaced with the column position. I don't want to print from 0. So instead of I, will give I plus 1 and j, and instead of j, we will use the j plus 1. Now we need to read the array elements, but till now we didn't created that two-dimensional array. So before starting this loop, we will create a matrix called mat and will initialize there itself with row size and column size. We can use the different syntax for to declare the variable. Here the square bracket can use after the variable or before the variable, or like this also we can write. But always in right hand side you have to give the row size and column size compulsory. So this is syntax for rectangle array. So that means like one more type is there called jagged array. In rectangle array, all the row will contains same number of column elements. But in jagged array, the column number may be vary in each row. That will discuss later. So here we are using the rectangle array and mat is the name of that array, and we have to give the row index value and column index value and use the sc.nextInt. So reading step is finished. Now we have to print. For printing purpose, we can use both type of for loop. First, I will show using the normal for loop. For printing, first need to handle the row. So int I equal to 0, I is less than. Either you can write directly write R or mat dot length you can write. Now column handling. We are using J variable over there. Either you can use C itself or mat of I dot length, or mat of 0 dot length is also okay because all rows contains same number of column elements. Now need to print the value. Here I will prefer printf for alignment. 5 space giving for each and every number and giving the mat of ij inside that. After each row, I need to print a new line. So we will give a blank line also there. Okay, we are running the program. We'll provide 2 by 3. First row, 3 elements. Now we can see the output. It's 2 by 3. So see the complete program. Now we will try to use the second type of printing statement. So I'll just comment out this one. 4. We have to iterate the two-dimension array. So each iteration will give a single dimension array back. So mat is iterating into x, or you can directly give I also, no problem. But these are not indexes, these will be values itself. First we are iterating one by one single dimension array into x from the two dimension. Then from single dimension array we have to iterate one by one element. Now we can use the printing statement over there. Here we have to print the y contains the value, and after each row we will print the new line also. Running the program again, just giving the size as 2 by 2. We can find out it's working properly. Now we will try some example program using the matrices. First I am trying matrix diagonal. Matrix diagonal is also known as main diagonal or right diagonal. With the example, I will explain it. If you want to find out the diagonal elements of a given matrix, it should be square matrix. The row size and column size should be same. Otherwise, we can't print that. Inside this example, it's like 4 by 4. And I will just mark the diagonal elements, main diagonal elements. 58, 25, 96, 36. This is the main diagonal elements from this matrix. Now we have to find out any similarities there inside this numbers. If you are checking the row and column positions over there, like 58, 0, 0, and 1, 1 is 1, 1, and 25 is 1, 1, and 96 is 2, 2, 33 is 3, 3. So the similarity is like all the diagonal values I and j value is same thing. If you are taking any other number, you can't find out the similarity. For example, take 44. This is 1 and 3. Like that, if you are checking any other number, you will not get this similarity. So now we have to implement this concept. Here I equal to j. We have to print that, right? I'm coming to the program. The reading step and printing step, I'm using the same thing. We can't use the second type of for loop because we need to cross check the indices value. So I can delete this. We will use this one where we will get the indices also. I'm just copy pasting the same printing statement downside for the diagonal. As I said, we can call it main diagonal or right diagonal. So simply diagonal or main diagonal or right diagonal we can call this. Before this printing, I will give a message over there. This is my matrix, and here we will try to give its right diagonal. Now what was the condition over there? I equal to j. So this printing statement I can control with I double equals j. If I double equals j, then only need to print this. So now our program is finished, but this will print line by line, or first number in first line, second number in second line, like that it will go. But if you want to print in a diagonal shape itself, then in else part, try to print same number of spaces over there, like this. Now we will run and check the program. And one more thing, like if it is not same size matrix, we should not run the program. Okay, anyway, first we will check whether it is working properly or not with the square matrix. This is correctly working over there. And if you want to make sure you are giving a square matrix, then that time what we will do? We have to cross check. If r not equal to c, then we have to terminate the program with some error message. So here I'm giving only square matrix, and we can terminate using system.exit function. As a parameter, just give 0. Without error we are terminating. And if you If you are not using system.exit 0, put the all other program inside the else part. Then also it's correct. We'll check whether it is working or not. Here I'm just giving 2 by 3, showing the error message and terminating that program. Now we will try another example. Next, we will try to print the off diagonal elements of a given matrix. There also we need the square matrix type. So I'm taking the same square matrix over there. This time you have to print the off diagonal, that is this. So here 55, 69, 52 and 12. These numbers you have to print over there. The next one, you have to find out some similarity between these numbers. So anyway, I and 0 equals, that is not possible over there. So I'll just check by writing I and j values. Take the first number 55. It's 0, 3, right? Second number 1, 2. Third number 2, 1. Third number 3, 0. Check the position again. Now I is incrementing, j is decrementing. But if you are trying to implement this one, you will not able to print the same way or same direction you can't print. So we have to find out another solution. Here just check if you are adding the I and j value, I plus j value, then here we are getting 3, 0 plus 3, 1 plus 2 is 3 and 2 plus 1 is 3, 3 plus 0 is 3 and 3 is the upper bound, or we can say this is equal to rho minus 1. So this is a condition, I plus j equal to rho minus 1. So this condition we will try to apply over here. Directly coming to the program, and instead of this ij, I will replace I plus j double equals rho minus 1. So only here I am making difference. And this is left diagonal, or we can say off diagonal. We will run and check the output. If you are trying to enter different size, then the previous error message we are getting over there. Here I am trying to give 3 by 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here you can see 3, 5 and 7 are the left or off diagonal elements. So the program is correct. Next we will try to print the border elements of a given matrix. Next we will try to print the border elements of a given matrix. So here the border elements, here you can see the first row, the last row, the first column and the last column. These are the border elements. So we need to find out some common factor in this border. It's difficult to find a common solution for all, but first row, first column, like that we can easily find out 4 solutions over there. So first I am taking the first row condition, row 1 condition. Here 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. That means all the I values are 0. Like that first column, if I am taking this one 0, 0, 1, 0, 2, 0, 3, 0. All the j values are 0. So second condition is j equal to 0. And again if you are taking the last row 3, 0, 3, 1, 3, 2, like that it's going. All the I values 3. So last row, all the I values are 3. And that is equal to, this 3 is actually row minus 1. And take the last column. There 0, 4, 1, 4, 2, 4, 3, 4, like that it's going. All the j values are 4. And that is equal to column minus 1. So all 4 conditions are there. All the 4 conditions we have to give over there. If any one of the condition matches, we have to print the array elements. So this if I will just replace with all these 4 conditions. First condition was I equal to 0 or j equal to 0 or I double equals r minus 1 or j double equals c minus 1. All the 4 conditions are given over there, and the message also changed over there, border. And now run the program. Here I am trying to give 3 by 4. One more thing, of course we can print the different sizes, but This is the previous example and we are checking the row and column size over there. That checking we don't need over there. So I will avoid this one and run the program again. Now I can give like 3 by 4 whatever. We'll give some random numbers over there. Now see, it's printing the border elements correctly over there. See the program again. Now one more program we will try. We will try to add two matrices. So for example, I'm taking 2 by 3 matrix over here for adding. If you want to add two matrices, both matrices should be same size. Then only possible to add. And the result also will be the same size matrix. We have to add the same position elements. That means like 0, 0 plus 0, 0. That is 1 plus 10 is 11. Like that, 2 plus 20, 22. 3 plus 30, 33. 4 plus 40, 44. 5 plus 50, 55. 6 plus 60, 66. So this will be the answer. Now using the program, we will try the same thing over there. Here we have to read two matrices over there. So first matrix is this one. I will give another message over there, matrix 1. And I need to repeat this step for the second matrix size also. So matrix 2. Here we will declare R1 and C1. Now we have to check the conditions if both matrices are same or not. If R not equal to R1 or C not equal to C1, either row is not matching or column is not matching, we have to terminate the program with some error message. Should be same size matrices and we have to terminate the program. We can use the exit 0 like in previous example. Now, if R and R1 is same and C and C1 is same, we can ignore the R1 and C1 because both are same concept only. Now, we need to create a second matrix over there. We will give the name as mat1 for the second one. We have to read both the matrices. So, we'll give a message. This is for matrix 1. And I don't want to give a prompt for each and every number. So, I will avoid this line. Now we have to read for the second one. So I'll just copy paste the same thing over here and will give us matrix 2. Here name is matrix 1. Now we have to print the matrix 1, 2 and 3. So matrix 1 I am printing over here. Same thing, copy pasting to print the matrix 2. Now we have to print the sum. For that printing statement again I am copying and writing matrices sum. Here you have to add both the matrix with same position. So it will be mat of ij plus mat1 of ij like this. And if you want to save the result in a third matrix, create a matrix 2 or result matrix with the same size, and instead of printing you can assign to that like result matrix of ij equal to mat ij plus mat1 of ij. So you will get the result in a third matrix. Now I will run and check this program. Here first I am trying to give different sizes 2, 3 and 3, 2. So should be same size. So it's not working over there. Now we will run and check the program. Giving 2 by 3 and 2 by 3. First matrix is 2, 1, 2, 3. We can either give like a matrix way or line by line. Matrix 2. Like this way also you can give. Now see the result. 1 plus 11, 12. 2 plus 22, 24. Like that it's giving the result. I think the program is clear for you. If any doubt, put in comment section. Subscribe the channel, like and share. Thank you for watching. Have a nice day.